All right, so with this one, the important thing is when you're doing these questions, an open cylinder means that we have a can which is open, and all we're really after is we're after this area shaded in green. We're after this curved surface area. Now, I've drawn a little picture here. If I think about like a poster, the curved surface is actually, if I was to open that up, you can see there that it looks like it's a rectangle. And a rectangle, actually, as it turns out, the curved surface is the circumference of the circle turns out to be this curved surface. And I guess we know that the area of a rectangle is length times width. So the length, though, as it turns out, is 2 pi r, which is the circumference of a circle. And the h, of course, is a height. So in order to do this question, we don't just plug numbers into formulas, because this over here, this 2 pi r squared, is only for the curved surface, or the area of this circle and the area of this circle. We're removing that. So therefore, my answer is the total surface area is equal to just the 2 pi rh, 2 pi rh. Now we know what r is in centimetres and height is, so we're just going and 2 times 40 times 80, and don't forget the pi, because that doesn't drop off. And what was saying to you girls is that if I get this and I multiply that in my calculator, that gives me 6400 pi. Don't go doing any rounding yet. Okay, now 6400 pi in your calculator was approximately 20,100 and something. Okay, now I'm not going to go ahead and do it, but the answer there to that one, it was closest to 20,000. Okay, much for this. Okay, so the important thing with this one to remember is how many sides do we have? Make sure you have all of the sides. When it comes to a cuboid or something along those lines like this, you've got 6 sides, yeah? So what we need to do is our total surface area, we've got 2, if you like, 2 times the area of 1, okay, plus 2 times the area of 2, and plus 2 times the area of 3. And you always will have that when it comes to a cuboid. The thing you've got to be careful of in a question, though, is if this was a box with the top cut out, if this was a box, an open box, you got to be careful, because we would only have 5 sides. If this was a box with the top cut out, the bit of shaded in blue here, you can see there that what we would have is we'd have 5 sides. So you just got to be careful with those. And this is the sort of thing that, that troubles students, because they just use formulas. So the total surface area is the area of our 6 rectangles. So that is therefore 2 outside of the length times width. I'm going to look at side 1. And that is 8 times 4 centimetres plus 2 times area 2, and area 2 has dimensions 10 times 4, and area 3 is equal to 8 times 10. I'm going to therefore say that that's 2 times 32 plus 2 times 40 plus 2 times 80, and remember that we're in area now, so we're looking at centimetres squared. So that's going to be 64 plus 80 plus 160, which is equal to 304, and you wouldn't get your full marks until you have our unit, which is centimetres squared. We're back in the room. Okay, so what we're going to do now is we're going to find the volume, although you girls haven't learnt this yet. Now the volume is equal to area times height. Now the thing is this area times height, we've got a cuboid. Now you can see that the consistent area, we could actually cut this in a number of ways. Think about, girls, if I was to ask you, if I was to cut this and to make, like this was a piece of cake, could I cut it this direction and give people equal slices? Could I do that? Yes, I could. So we could actually do it a number of ways. Could I cut this cake and in this direction here?
Yeah.
Yes, I could. So it doesn't really matter which way you do it because we have a consistent cross-sectional area. The question is though, could I find, what about if I had a cake which looked like this? Could I cut equal slices if I was to cut it this way? No, I couldn't. So what you need to be careful is with volume, when it comes to consistent cross-sectional areas, you need to have a consistent cross-sectional area to multiply by a height. Okay, now let's go ahead and do this example. All right, let's work out the area. If I was to work out the area of, say, over here, if I was to work out the area of the top, then I could then multiply that by the height, and that's going to give me the volume. All right, so what is the volume of this shape? What is the area, girls, of the top rectangle, the thing I've just shaded in red? What is it? Volume is equal to the area. What is that area? What is that area over there? What's the area of that rectangle? The one in red, the top of the box, if you like. The area is 8 times 10. Yeah, no, it's 8 times 10. Okay, so the area is equal to 8 times 10. And what's the height of this box? Times 4. Beautiful. Now, of course, in mathematics, we could do it a number of ways. 8 times 10 is 80, times 4 is 320. Now, given that volume takes up space, what is the unit we're looking at? Centimetres cubed. Okay? So volume is always in cubic centimetres or metres or whatever. And if you think about it, we could have done it another way. We could have worked out that our volume could have been equal to, we could have worked out a different rectangle, and we could have said 8 times 4, which is 32, and times that by 10, and you're still going to get the same result. 32 times 10 is equal to 320 centimetres cubed. So the important thing is when doing volume is you have to have a consistent cross-sectional area. And so when it comes to doing the volume of this shape over here, you need to have a formula. Okay? So I'm going to pause the video there now and we're going to have a look at some other questions. So I was talking about volume is equal to area times height. But girls, if I was to be cutting this, if this was a piece of cake, what could you tell me? Could I cut it this way and give people equal slices of the pie? No, because you can see there that it's a circular shape. However, would you agree that if I cut like so around in a circle, would everyone be getting the same slice provided that these depths here are the same? Yes. So the area is what though? The area is this cross-sectional area which we know to be a circle. Now what is the area of that circle though? The area of a circle is equal to pi times r squared. Okay? And the height, we're given the height in the question. So the volume of this cylinder is quite simple. The volume is area times height, but the area is pi times r pi r squared times the height of the cylinder, and that's the volume of my cylinder. Now, be careful though, because I've been given what? The diameter or the radius? I've been given the diameter, so be careful. So the volume is equal to pi times the radius squared. The radius is half of 80, which is 40 squared times the height. Now, be careful. I'm asking you to do it in centimetres. Okay? How many centimetres are there in 1 metre? Centi. Think about century. How many years there's 100 years, so centimetre. There's 100 centimetres in a metre. All right, so you've got to be careful. what a lot of students do is they go ahead and they put in 1 for the height. Is that going to help us? No. So you've got to make sure you're in the same unit. Okay? So height is 100 centimetres, and therefore now what we can do is we can do that in a calculator. Now you've got to be careful, don't go doing any rounding off, but 40 squared, I'm going to do in my head, is 1,600 times 100 is, add 2 zeros to that, 1,600, 16,000, 160,000, 160,000 pi, and you can do that in your calculator. Okay, so I'm going to do that in my calculator now. 160,000 pi, it might have even been easier to do it in metres. Okay, but 160,000 times pi, and that's going to be a massive number, but that is going to give me 502,655 centimetres what? I've found volume, so what unit is it? 502,655 centimetres cubed, because it's volume, okay? Volume takes up space, space takes up 3 dimensions. Make sense? Yeah. All right, so I've just taught you volume of a cylinder, and we've looked at the total surface area of a cylinder. All right, so I'm just going to pause the video there and we'll look at another example just before we go. All right, so what I wanted to do now is I wanted to go through 2 things. I wanted to go through finding the total surface area and the volume of these solids. Now, you can see there that when it comes to over this, there's no consistent area. It's not an easy thing. So you actually have formulas for some of these shapes, which you'll get to. The total surface area for a sphere is equal to 4 pi r squared. Okay, that's just a formula you need to know, and when you'll have your cheat sheets and stuff, you'll have it on there. So what we need to do, if it's 4 pi r squared, then that is 4 times pi times the radius squared. Are we given the radius or the diameter? Girls, what are we given the radius or the diameter? So what's the radius then in metres? It's 5. Good, and be careful, it's squared. Now, let's try to leave things in exact values. 5 squared is 25. 25 times 4 is 100. So that's going to be 100 pi. And it says here correct to 2 decimal places. So can you please tell me what 100 pi is correct to 2 decimal places, please? Okay, so you'll notice that it's 314 correct to 2 decimal places, 0.16, so we're rounding up 0.159, we're rounding up the second and looking at the third decimal and rounding the second up. So the answer is 314.16 what? Bananas, 314.16. Are we in? It's in metres. And is it, look, it's area. So are we looking at? Squared. Thank you very much. Awesome. Okay, so we've just found the total surface area of that. Now I'm going to tell you, this is the same thing. The volume of that sphere is, once again, it's a 4/3, I believe it's 4/3 pi r cubed is the volume of a sphere. Okay? Now, 4/3 pi r cubed, it's straight off the formula sheet, and we're asked to find the volume. So this time we've got 4/3 times pi times, be careful though, it's r cubed. And our radius is 5. Now I'm going to go ahead and do that, and that's cubed. 5 cubed, do it in calculator, it was 125. 125 times 4 is 500, so that's going to be 500 on 3 pi. And if you do that in your calculator, you're going to tell me what it is to 2 decimals. All right, so you should have got 523.60 metres cubed. All right, and the last question we'll do before you girls probably want to get home is this one. Total surface area of a cylinder. Well, first of all, the total surface area, we discussed that there's 2 things. There's 2 circles, so the total surface area, you don't remember off the formula sheet but this is not an open cylinder. So 2 pi r squared is the 2 circles, plus the curved surface, and the curved surface we discussed is that rectangle which has The length of that is 2 pi r, which is the circumference of the circle, and h is the height. So that's the total surface area of the cylinder. So now what we have to do is just go and plug our values in. The two unknowns are there and we're asked in centimetres. So what we're going to do is our total surface area is 2 times pi times r, which is it's 3 squared plus 2 pi r times h, which is, so 2 pi r is 3, 2 pi times 3 times our height, which is 7, and I'm going to do that. That's 9 times 2 is, so that's going to be 18 pi plus 7 times 3 is 21 times 2 is 42. Look at that. I don't have to even do anything because I can then go that that's 60 pi. 18 plus 42 is 60, and now I go ahead and work it out in my calculator, which of course is 60 times pi is equal to 188.496. I'm rounding off to 2 decimal places, so it's 188.50. What units have I got? Centimetres squared. Thank you very much. And the last thing is, and we discussed this, the volume is the area times the height. What area are we after when we're looking at a cylinder? The only way to cut this cylinder into equal slices is looking at what's the area? The area of a circle. So the area of that circle is pi times r squared times the height, which we'll later on work out. So the radius is equal to 3, so it's pi times 3 squared times 7. So that's going to be 9 times 7 is 63 pi. And we work that out into our calculator, and that is going to be equal to 197.92. What is it? What's the unit? What is it? Centimetres cubed. Make sense? How are you feeling about total surface area and volume? Good? Hopefully I'll see you next week then. All right, I'll stop this video. No problem.